Now recording. So, today we're going to be doing stuff with Visual Studio and C Console apps. So, I'm not going to waste half the 1 hour class just loading Unity. So, if you don't mind, please load Visual Studio. There is actually no way to, is that better? That's good. This isn't one of those rooms that has like one bank of lights and dimmables. Skip. Start. So, create a new project. C Console app. We can call it week 2. Yeah, week 2 is good. Wait, what? I hope it doesn't do that a lot. All right. So, today we are going to get a little bit more practice with variables, and we are going to explore the wild and crazy world of expressions and operators. So, let's first discuss operators for the integer type. So, let's say we have an integer. Please follow along and type this out. Let's say we have an integer x being assigned 5, an integer y being assigned 10, and then an integer z. Go away, you stupid autocomplete suggestions. Thank you. I do not accept you. Integer z is equal to x plus y. There should be no surprise what the result will be. Anybody?
15.
15. There we go. Does this increase in size? Only marginally, though. That's still pretty small. 15. So, to recap, a variable is a segment of memory, which is, wait, are there people out there waiting? There were people milling about looking like they wanted in the room. They went away, so that's good. So, a variable is a little piece of memory which we have set aside for our program. So, if we imagine this large cylinder to be our memory, computer memory is often represented as a large cylinder. The first line that contains anything, line 3, says, I want you to pick a little spot in memory. We assign that the name of x, and we insert into it the value 5. Line 4, we declare an integer y. So we pick a little box in memory the size of an integer, and we assign it y. Note, as of line 4, we have not filled the box with anything. It is an uninitialized value. So the question is, what does it fill it with? Because we know that computer memory always must be in a deterministic state. It must have some hard, concrete value. Anybody care to guess? 1? Okay. Anyone else? 0? Let's take a look. Console.write line y, h, y, save. We get an error. So, what happens in this situation depends on which language you are using. If you are using Java, you would have been right. Java, when you initialize a variable but you don't assign a value, puts some default value that kind of makes sense in there. For integers, its default is 0. In C, it would just give you whatever was at that memory address when you assigned it. So random garbage, essentially. Smelly, smelly garbage. In C sharp scans through to see if this operation is possible. It doesn't assume what you want in there. If you haven't initialized the variable, you can't use it. You can think of it as a blank waiting to receive some data. But again, this is one of these low-level decisions that vary from language to language. Make sense? So on line 6, what do?
Give it a value.
We give it a value. What is that value?
10.
10. Right there. Good. On line 7, what do? What are we doing? What's the first thing we're doing? Yes?
We're adding values.
Are we doing that first or second? We're, well, I mean, that's what the code says, but I'm asking, what does the computer do? Yes?
So like first is trying to insert C and then do what's it called, the equation afterwards?
Right. So the first thing that it does is it declares the variable z. So it sets aside a little box in memory for the of integer size for the calculated result of whatever calculation you do. In this particular case, what expression are we computing? X plus y, the value being 15. X is read into the CPU, y is read into the CPU, 15 is calculated, and that value is put back here. Make sense? This is how variables work. So, there are a whole host of arithmetic operators. We have addition, subtraction, multiplication, and division, all according to their standard definitions in standard mathematics. But there's another one which is considered a standard arithmetic operator in computing, which you may not have heard of before. Anybody know what this does?
Percentage?
It is the percent sign, but the name for this, when used as an arithmetic operator, is modulus, which is a nice $10 word. Modulus. So, the modulus is the remainder of integer division. So, everybody remember long division? Pardon me. Remember long division from grade school? Hopefully they still teach that. They still teach long division? Okay, good, because I had heard a few years ago something about them phasing out long division. And I was like, that's not even math anymore. Can't get rid of long division. So, when you perform long division, right, if you have something like 13 divided by 5, right? You subtract the 10, you put the 2 here, remainder 3, right? This is the modulus, okay? So the modulus can be, so it's a little out of the way, but it's used for a number of different practical applications. If you have a counter, right? If you have a number which is, linearly increasing over time, if you apply, say, if this is 10, then and this is x, then, if this is x, then this line that would be x mod 10. So you can turn a linearly increasing signal into a periodic signal using modulus. In digital signal processing, this is called a sawtooth wave. It's also a counter that wraps around, is another way to think of it. So the other thing that modulus is often used for is for testing divisibility. So when the remainder comes out 0, we know that the quotient was perfectly divisible by the divisor, right? So you can, for example, check to see if a number is even or odd relatively easily. What would we use to check that with? Mod what? To check for evenness or oddness?
2.
Correct, mod 2. So, for example, if I say if x mod 2 is equal to 0, console.write line, x, say x is even, it is true of even or odd numbers that a number is either even or odd. There is no third state when it comes to evenness versus oddness. So if it's not odd, or if it's not even, it's odd. Yes. Get rid of the junk line there. There we go. There we go. And it's a little hard to read, but we do get x is odd here. Does this make sense? So, that is integer modulus. Modulus is the remainder of integer division. It should be noted. Programming languages recognize a distinction between integer division and real number division. They often load on the same operator, but let's pick some numbers that are not evenly divisible. It's like, how about a prime number? There we go. So Z will in this case be 17 mod 4. Any quick maths? Anybody know what the remainder of that is going to be? Hmm? 1. One indeed. But how about division? Four. Now, in regular mathematics, 17 divided by 4 would be
Decimal.
hmm?
We're gonna have a decimal, not whole
If you weren't doing a remainder and you were calculating it as a decimal. Yes?
Would be 4.25, right?
Correct. 4.25. Where's my 0.25?
It's an int, it exists.
Exactly. Integers don't carry decimal points. So, here's how it works. If we have x and y, x divided by y, if x and y are integers, then x divided by y is also an integer. It preserves the type, which means that if this division would have resulted in something after the decimal point in normal mathematics, there's no place to store that inside of an integer. So it drops it. And it doesn't round it, it drops it. Right? For example, if I modify this program slightly to say 19 instead of 17, I still get 4. I'm not rounding up to 5. All right? Make sense? So far, so good? Question?
I'm confused about the brackets. Like, this would really not work. If you move the
Yeah. Okay. These guys?
Yeah, so like the console.write line is indented. Is that required? And then like the else is outside of. So like else is at the end of one of your brackets when you start another one.
So, okay. So, if statements. Alright. I'll return to you, chart. So, an if statement is a conditional statement, right? In this case, if I draw on this board, you can see it? Yeah. So, in this case, if you were to do this as a flow chart, you would come to a decision x mod 2 is equal to 0 If that's true, you follow one path. If that's false, you follow another path. In this case, true, we're printing x is even. False, we are printing x is odd. After either of these execute, control rejoins, and we continue on with the program.
It's more so a question about just
The syntax,
formatting.
yeah.
Because I just feel like I'm hitting buttons and like it's just going all over the place. I just need to work on it, I guess.
So, to answer your particular questions in a different order than you asked them, the indentation here is convention, but it is not required. However, it is, well, at least as far as the compiler is concerned, they're not required. As far as this course is concerned, that is an element of documentation. So if you have indentation that's all over the place, I reserve the right to lose to documarks for it. What the opening curly brace does is it says we are opening a new code block. So the first code block in an if statement corresponds to the true branch here, right? You can imagine if I had several statements to execute, not just one, I would have several statements in here, right? For example, perhaps if x is even, y should be set to, 8, whereas if x is odd, y should be set to 10. Something like that, right? Go away, blinky light. So, this is a code block. Whenever you create a new code block, that block should be indented one level from previously, right? This also applies in Unity, you may have noticed this as well. When all of the classes are at the top level, they're at this indentation level 0. All of the methods are at indentation level 1. Anything inside of a method is at indentation level 2. And then if you had an if statement inside of there and something like this, this would be at indentation level 3, right? As you go along, if you become a kind of competent but not that competent programmer on your way to becoming an expert programmer, you will pass through a phase where you will have, your code will be over here and wandering around like that. That's how, that's the level of indentation you will have on your programs. And that's because you're not using modularity properly and you're not using functions correctly. But, still, it'll work, it'll be technically correct, but, you'll cause yourself more hassle than you need to. The level of indentation, if you want a good rule of thumb, the level of indentation that you have on any particular program probably doesn't need to exceed 5 or 6 levels. That's usually sufficient for most purposes. I mean, if you're doing something, if you're doing something wild, then you can have more. You can have as many as you want, but it gets difficult to read after a certain point. Does that make sense?
Yeah.
So,
So Rick, how many levels are these? What about this one?
well, at the moment, this is level 0, and this is level 1. But this is because the console app view here is hiding a few things from you. In C#, everything must be in a class, and anything that executes in a console app must be inside of a method named main, but because that has to be done every time, they're just hiding those facts from you. So as far as the compiler is concerned, things are at indentation level. This would be 2 if we included the information that's being skipped, right? But We are simplifying things so that we don't have to worry about all of that. Just worry about what's here. Incidentally, the compiler itself in C# does not care about indentation whatsoever. You can have things at very wrong levels of indentation. You can put big spaces in your lines. You just can't split identifiers. Like that. You can run that, and it runs. It doesn't even give a warning. But I ask you, how readable is that? Please don't write your code this way. So, there is fortunately a way to get yourself out of this kind of trouble automatically. I think it is, where is it? There's lots of good stuff in this menu. Gonna have to look it up. Visual Studio. Visual Studio! Alright. Control K, Control D. Okay. So Control K, Control D. And there you have it. Control K, Control D will remove all of the, non-standard indentation. If you write your code however you want, but you Control K, Control D before you submit it to me, I will not remove any marks for improper indentation. Yeah, so the code blocks are quite important. It really makes a difference when, like, a common mistake that people make, and I saw a few people making it yesterday, is to add code that you intend to be in a code block up here, down here. Like, for example, when we were adding code to methods in Unity, I saw a couple of folks, like, adding a line here, asking me, why am I getting a compiler error? And it's like, because your statement is outside of any method, so it doesn't make any sense, right? So the code blocks are important. It's important, like one of the first hazards you'll run into is just where you have put the line of code, right? Make sense? Question?
Where should be?
Well, in this case, it doesn't matter because there's no method here. But if you're in Unity, lines of code like this that are manipulating variables, those must go inside of a method. So the start method, the update method, fixed update, on destroy, those things. Does that make sense?
So what's the difference between a method and an if statement?
Good question. An if statement allows you to select between different statements. A method is more similar to a function in mathematics. Back in the good old days, they used to call these subroutines. So we're kind of jumping a little bit ahead in the course, but public int, no, just say int f takes integer and why are you complaining? we go. So this is how you define, this is a very, very simple method. We specify that it takes some input n. We say that its return value or output is n times 4. So this is a very simple method. All it does is takes an integer in, multiplies it by 4, and returns it. So instead of writing line z, we could say write line f of z. Whereas before we were getting 4, we are now getting 16. So that's what a method is. But these methods are hooked up to be triggered, like in Unity particularly, these methods are hooked up to be triggered by specific events that happen in the game, like the creation or destruction of a game object. They're a very, we have literally only just dipped our toes into methods because I want to get back to my chart.
Yes, sir.
That's okay, these are excellent questions. But yeah, a completely different thing from an if statement. Although, methods can have if statements in them. So, where was I? Ah, yes! Division. So, with the division operator, if both of the numbers that go into the operation are of the double type, and remember, doubles are real numbers, they have decimal points, then the result will also be a double. But, does anybody care to guess what we get in this case? If we have a double and an integer that go in, what do we get as a result? Yes,
And?
int? Let's try it. So, let's say int q is equal to 100. Int
Double?
make it p and q. P is 100, oh, and that's double. Q is equal to 23. Console dot write line. What did I say? Double divide by the other one? So Q divided by P. What do we get? We get 0.23. So, we get a double. The output of that operation is a double. Similarly, if you swap these, you still get a double. So, the reason that it does this is that even if the number going in here is a whole number, anytime a double is involved, double to integer conversion potentially loses information. The programming language will try not to lose information without your explicit consent. So, when it sees one of these being a double, it will produce a double as the result. So it will gobble the integer rather than maintain the integer. Does that make sense? Okay. Cool. do comparison operators. So we have a lovely little if statement here. I'm just going to truth and falsity. So, in the same way that we have a whole suite of arithmetic operations, we have a gaggle of comparison operations for use in producing Boolean results. Boolean results being those expected by if statements. So, the one that we've been using so far is two equal signs. This is equality. Tests for equality. Like so. Exclamation point equals tests for inequality. So, here, if x has the same value as y, under equality that will be true. In this case, if x does not have the same value as y, the result will be true. Right? This is actually the same as not x equals y. This is the logical inversion operator, Boolean not, the not operator. The parentheses are actually not required, not x. So, this is called a truth table. So, if we apply Boolean negation to x, true becomes false, and false becomes true. And that's it. Very simple. X equaling y, this is, So it's not, let's stick to logic operators then.
Yeah.
Two ampersands. Two ampersands is logical and. Let's play a guessing game. What is true and true? True or false?
False.
True.
Yes. True and true is true. What is true and false? True or false? False. That's right. False and true?
False.
False. And false and false? false. So, think about these true and falses in terms of propositions, and this makes it a little, makes it a little bit easier to digest. Let's imagine that X is today is Tuesday. Sometimes that's true, sometimes that's false. Y is, it is raining. Right? Sometimes that's true, sometimes that's false. Less frequently than it's a Tuesday. So, if it's true that today is Tuesday, and it's true that it is raining, is it true that it is both raining and Tuesday? Yes. If it is not Tuesday, and it is not raining, is it true that it is both Tuesday and raining? No. So, false. So, any questions about logical and? Logical or. So, in terms of propositions, here, X or Y would be it is either raining or Tuesday. So, if it is both, okay, so let's actually start with this one, all right? Let's say today is Tuesday, but it is not raining. Is it true that it is either raining or Tuesday? Yes. So that is true. And conversely, this one. No demonstration required. If it is not Tuesday and it is not raining, is it either raining or Tuesday? No. So that comes out false, right? It is not raining, it is not Tuesday, therefore it is neither raining nor Tuesday. Now for the fun one. Let's say that today is Tuesday and that it is raining. Is it true that it is either raining or Tuesday? How many people think yes? How many people think no? Wow, that's like perfectly split opinion. So, in mathematical logic, that statement is true. If either one of these things is satisfied, the whole thing is satisfied. That's what or means in a logical sense. So, if it is either raining or Tuesday, and it is both raining and Tuesday, it is, this is true. The half of the class that didn't get that correct, there's a different operator that you might like. Exclusive or. So, the exclusive or is basically the same as regular OR. The only difference is it followed your intuitive sense of this example. So, it's a little bit like saying at the end of here, it is either raining or Tuesday, but not both. That's what exclusive OR adds to the end there. By the way, when people are writing it, they will often write it XOR for exclusive OR. Like it's a type of logic gate that gets integrated into circuitry and that sort of thing. Yes?
Is there ever an issue where the compiler thinks that you're trying to do a power to instead of an exclusive OR?
Oh, Am I doing this in the wrong language? Let me see this for a second. Uh-oh. I might be thinking Python. C#. Yeah. No, I'm right. So it's overloading the operator. This guy, if it applies to integers, it performs raising to a power. I should put that one on the list that I now erased. But yeah, that is exponentiation. But if you apply it to true-false values, it performs exclusive OR. Like that. Make sense? So normally, you're not going to be doing these on like direct true-false values. There's really no point in saying something like, oh, you know, if true and false, right? You wouldn't just throw literals in there because like that's just false. You might as well say, you know, if false, in which case you might as well say nothing at all because that means you're always executing one of those branches and never the other one, so why have the if statement in the first place, right? So, these things, most of the time, will be conditional tests. We have talked about equality and inequality, but there are a few others that we should go over before we run out of time. Oh, shoot. Greater than, less than, greater than or equals, and less than or equals. They do what they did say on the box. That's it. All right, thank you very much. Very quick example. X is greater than Y. There you go. Run. Truth. As X is 19, Y is 4. So X is greater than Y, so it executes this branch. There you go. All right, any questions?
Your projector's not on.
Oh!
We could just come over.
Very quickly.